I am Amrita from Department of Electronics and Communication Engineering, and my Tech Talk topic for data structures is evaluating the readability of force directed graph layouts, a deep learning approach. So this topic tells the readability of the force directed graph layouts. Coming to the introduction, force directed graphs are a popular method for visualizing complex data relationships. Their layout depends on physical simulations that model attractive and repulsive forces among nodes. Understanding their readability is crucial for effective data interpretation and decision making. So, by understanding the readability of this force directed graphs, it's very important for the effective data interpretation and the decision making. Coming to the importance of readability in graphs, readability directly influences user comprehension and interaction with graph visualizations. So by this readability in these graphs, it will further improve the interaction with graph visualization and it influences the user comprehension. Poorly designed graphs can lead to misinterpretation and hinder effective analysis. So this different poorly and very not designed means not poorly designed graphs can lead to the misinterpretation and hinder effective analysis. Evaluating readability is therefore essential in optimizing graph layouts for end users. So in this right side we can see the picture, the importance of improving readability. So these are some of the percentages so that we can see about the scoring texts which are very low. Here coming to the first one, 17%. 17% of lowest scoring texts are too complex for their audience. Second, 13%. 13% of low scoring texts are too simple for their audience. So 17% is too complex and 13% is too simple. And coming to the 51% of low scoring texts have paragraphs that are too long. Coming to the 90 words, the average length of paragraphs that are too long. So here 51% and 90 words, here we can see the average length of the paragraphs. And here 43% of low scoring text have sentences that are too long. 28 words, the average length of sentence that are too long. So 43% is about the percentage of which the sentences that are too long, and these sentences contain the 20 words. This is the average length. Coming to the 41% of low scoring texts have words that were too complex. So here 14 characteristics are involved. So this is the average length of words that are too long. So 41% is a perfect which are too complex, the words which are too complex, and 14 characters are the average length of the words. Coming to traditional methods of readability evaluation. Traditional methods often rely on heuristics and subjective assessments. These methods can be inconsistent and vary greatly between different evaluators. There is a need for more objective and scalable evaluation techniques in this field. So there is a need for the objective and scalable, means in particular in the perfect evaluation techniques there is a need. And coming to the assessments, here we can see traditional assessment and authentic assessment. In traditional assessment, it generally relies on first choice written measures, relies on proxy measures of student learning to represent target skills. Here it relies on the direct measure for target skills. Encourages memorization of correct answers. Goal is to measure acquisition of knowledge. Here the goal is to enhance the development of meaningful skills. Coming to this point, curriculum directs assessment. Here the assessment directs curriculum. It's quite opposite. And coming to the next point, emphasis on developing a body of knowledge, emphasis of ensuring the proficiency at real world tasks. Here on traditional assessment, promotes what knowledge and promotes how knowledge, provides a one-time snapshot of student understanding, and it provides an examination of learning over time. It emphasizes the competition, it emphasizes the cooperation, and it targets simplistic skills or tasks in a concrete singular fashion. And coming to the next point, it priority on summative overcomes or product, and this in the conducting assessment, it prepares students for ambiguities and exceptions that are found in realistic problem settings. And next point is a priority on the learning sequence of process. Coming to the next slide, introduction to deep learning. Deep learning is a subset of machine learning that uses neural networks to analyze data. So this deep learning, which is a subset of machine learning, so it uses some of the neural networks to data analyzation, and it has shown great promise in various fields including image processing, natural language processing, and more. This approach can be leveraged to evaluate graph readability by analyzing visual features. Coming to the features for readability evaluation. Key features for evaluating graph readability includes node density, edge crossings, and label clarity. These features can be extracted and quantified using deep learning models. The model can learn to associate these features with human judgments of readability. So in this the picture we can see evaluating the readability of graph layouts. A deep learning approach could we evaluate the readability of a graph layout by directly using layout images. Demonstrate effectiveness of a deep learning based approach for evaluating the readability of graph layouts. Application of convolutional neural network for fast and scalable evaluation of graph readability. These are the features for the readability evaluation. Coming to dataset preparation. A robust dataset is crucial for training deep learning models effectively. We can create a dataset by collecting various force-saturated graphs with known readability ratings. This dataset should include diverse graph types to ensure the comprehensive learning. So this data pre-processing includes data integration, data transformation, data reduction or dimension reduction, and the data cleaning. This is the overall cycle of the data pre-processing. Coming to the model architecture, the deep learning model can be designed using convolutional neural networks (CNNs) for image-based analysis, and the architecture should be tailored to capture spatial relationships and patterns in graph visualizations. Training the model involves adjusting parameters to minimize the difference between predirected and actual readability scores. So in this picture you can see the convolution neural network. This is the input, pooling, and the output. We can see input by feature maps and output for the fully collected layers. Coming to the evaluating the metrics, several metrics can be employed to assess the performance of the readability evaluation model. Common metrics include accuracy, precision, recall, and F1 score, among others. Comparing these metrics against the traditional evaluation methods can highlight the effectiveness of the deep learning approach. These are 21 employee performance metrics. First one, management of objectives. Second, subjective appraisal by managers, product defects. And fourth one is the number of errors. Fifth one, the net promoter score. And sixth one is the 360-degree feedback. Seventh one is 180-degree feedback. And eighth one is the force ranking. And ninth one is the number of sales. And 10th one, the number of potential client contacts. And 11th one is the number of phone calls. And 12th one is the number of company visits. 13th one is the number of active leads. And 14th, the number of units produced. And 15th is the handling time, first call resolution, contact quality. And coming to 16th, work efficiency. 17th, revenue per employee. 18th, profit per FTE. 19th, human capital ROI. 20, absenteeism rate. And 21st is the overtime per employee. So these are the 21 employee performance metrics. Some of the evaluation metrics. Case studies and results. Implementing this approach can provide insights into the most readable graph configurations. Case studies can demonstrate the model's effectiveness in real-world scenarios. Results can show a clear trend towards improved readability assessments compared to traditional methods. Coming to the conclusion and future directions, evaluating the readability of four-sided graphs using deep learning offers a modern solution to a age-old problem. So by this evaluating the readability of row-directed graphs, we can influence the directed graphs and we can know the interaction of the particular graphs. The future research can explore the integration of this approach with interactive visualization tools. Ultimately, advancing this field can enhance data visualization practices and improve decision-making process. By this advancing field. Thank you.